The engineers who designed your truck spent years studying component failure rates, analyzing warranty claim data, and running durability simulations to determine exactly how long each part would last under normal operating conditions. You might assume this research aimed to maximize reliability, to ensure every component would provide decades of trouble-free service, but that assumption misses the fundamental economic reality driving modern automotive design. Those engineers were not trying to make parts last as long as possible. They were trying to make parts last exactly long enough, calibrating failure points to occur at strategically advantageous moments that maximize manufacturer profit while minimizing warranty liability. The result is a truck filled with components deliberately engineered to survive just past the typical warranty period, then fail predictably, generating repair revenue that has become essential to dealership profitability as new vehicle sales margins continue shrinking. Are parts specifically designed with planned obsolescence built into their fundamental construction? These are not low-quality components that fail due to poor manufacturing. These are precisely engineered assemblies that will function flawlessly for a predetermined number of miles, then degrade rapidly once they reach the failure threshold the designers intended. And the truly insidious aspect is how invisible this planned failure remains until the moment it occurs. How normal everything seems until you are suddenly facing a repair bill measuring in thousands of dollars for a component that should never have failed in the first place, but was always going to fail at exactly this mileage. Start with the throttle body, a component that controls airflow into your engine based on accelerator pedal position. In older trucks, this was a simple mechanical linkage, a cable running from the pedal to a butterfly valve in the intake, a system so reliable that it could last the entire life of the vehicle with zero maintenance beyond occasional lubrication. Modern trucks use electronic throttle control, replacing that cable with sensors, motors, and computer management. The manufacturers claim this improves response and enables advanced features like cruise control and stability management, and technically these claims are accurate. But the real motivation for this change becomes clear when you examine the failure patterns. The throttle body assembly in a modern truck contains a small electric motor that physically opens and closes the throttle plate based on signals from the accelerator pedal position sensor and the engine computer. This motor uses plastic gears, specifically engineered to wear at a predictable rate, not metal gears that would last indefinitely, not even high-quality plastic that might survive 200,000 miles. Cheap plastic gears designed to strip and fail at approximately 80 to 120,000 miles, right outside the typical powertrain warranty coverage. When these gears strip, the throttle stops responding properly, creating dangerous conditions where the engine suddenly surges or fails to accelerate, and the only repair option is replacing the entire throttle body assembly at costs ranging from $500 to $900 depending on your truck model. The critical detail here is that this failure is not random bad luck or the result of defective manufacturing. Every single throttle body installed in your truck model will fail at roughly the same mileage, because the plastic gears were engineered with specific material properties and tooth profiles that guarantee failure within this window. Engineers could easily specify metal gears or higher quality plastic that would eliminate this failure mode entirely, adding perhaps $12 to the manufacturing cost. But doing so would eliminate a reliable revenue stream that generates hundreds of millions in service department profits across all the trucks this design affects. Move next to the fuel pump assembly, hidden inside your gas tank where you cannot see it, cannot monitor its condition, and have no warning before it fails. Older trucks use simple electric pumps with brush-type motors, basic proven technology that could easily last 300,000 miles. Modern trucks still use electric pumps, but the design has been deliberately modified in ways that guarantee earlier failure. The pump motor now uses a commutator design with carbon brushes that wear at a predictable rate, and the fuel sock, the filter screen that prevents debris from entering the pump, is made from material that degrades when exposed to ethanol in modern gasoline. The manufacturers know exactly how this degradation occurs because they tested it extensively during development. The ethanol slowly breaks down the filter material, allowing it to shed particles that circulate through the fuel system. These particles accelerate wear on the carbon brushes in the pump motor. The brushes wear down to the point where electrical contact becomes intermittent, causing the pump to function erratically. This process takes approximately 90 to 110,000 miles under normal driving conditions, again conveniently just outside warranty coverage. When the pump begins failing, you experience symptoms like difficulty starting, loss of power under acceleration, or the engine dying unexpectedly, dangerous conditions that force immediate repair. The replacement cost runs between $800 and $1,400 because you cannot simply replace the pump motor. The entire fuel pump assembly must be replaced, requiring dropping the fuel tank, a labor-intensive job that takes several hours even for experienced technicians. And here is the critical point that proves this is planned obsolescence rather than unavoidable wear. Heavy-duty fleet trucks, The ones sold to commercial customers who track total cost of ownership religiously and will not tolerate premature failures, use completely different fuel pump designs with metal filter screens and brushless motors that routinely last 300,000 miles. The technology exists to build reliable pumps. Manufacturers choose not to use it in consumer trucks because the failure generates profitable repairs. The automatic transmission valve body represents perhaps the most financially devastating planned failure point because transmission repairs carry such high costs that many owners face difficult decisions about whether to fix the truck or replace it entirely when this component fails. The valve body is the brain of your automatic transmission, a complex assembly of passages, solenoids, and check balls that directs hydraulic pressure to engage different clutch packs and create the various gear ratios. In older transmissions, valve bodies used simple hydraulic controls with minimal electronics, and these units could last the entire life of the transmission with only occasional cleaning. Modern transmissions use valve bodies packed with electronic solenoids, pressure sensors, and computer-controlled valves. These components operate in an incredibly hostile environment, submerged in hot transmission fluid, subjected to constant vibration and pressure cycling, and required to function with extreme precision hundreds of times during every drive. The solenoids use coil windings and moving plungers sealed with rubber O-rings, components that will inevitably fail given enough time in these conditions. The manufacturers know the failure rate curves precisely because they tested thousands of solenoids to determine how long the windings can handle the heat before insulation breaks down, how many cycles the plungers can survive before wearing enough to cause issues, how long the O-rings remain effective in hot fluid before hardening and leaking. The answer to all these questions is approximately 100 to 130,000 miles, and this is not coincidence. The components could be designed more robustly. The solenoids could use better wire insulation. The O-rings could be made from materials that resist heat degradation longer. But these improvements would extend component life beyond the point where failures generate maximum service revenue, so they are not implemented. Instead, the valve body is engineered to function perfectly through the warranty period, then begin developing issues right around 100,000 miles, manifesting as harsh shifts, slipping between gears, or failure to engage certain gears properly. The repair requires either rebuilding the valve body, which costs $1,200 to $1,800, or replacing the entire transmission, which runs $6,000 to $10,000. And because these symptoms often develop gradually, many owners attempt to delay repairs, which typically makes the problem worse, as damaged solenoids allow incorrect pressure levels that accelerate wear on clutch packs and other transmission internals, transforming what could have been a valve body repair into a complete transmission replacement. The turbocharger wastegate actuator in diesel and many modern gas trucks follows this same pattern of engineered failure. The wastegate controls boost pressure by opening a valve that allows exhaust gas to bypass the turbine wheel when pressure exceeds desired levels. Older turbochargers used simple mechanical wastegates controlled by a spring and a pressure-sensing diaphragm, reliable systems that lasted as long as the turbocharger itself. Modern trucks use electronic wastegate actuators, small motors that precisely control the wastegate position based on computer commands, allowing more sophisticated boost control and better performance. But these actuators are mounted directly on the turbocharger, where they experience constant exposure to extreme heat, sometimes exceeding 400 degrees Fahrenheit during normal operation. The small electric motor inside the actuator uses plastic gears and electronic components that simply cannot survive this heat indefinitely. The manufacturers know this because durability testing revealed the failure patterns clearly, but the improved boost control justifies the design in engineering reviews, and the planned failure at 90 to 110,000 miles generates service revenue that financial analysts appreciate. When the wastegate actuator fails, boost pressure becomes uncontrolled, either too high, which can damage the engine, or too low, which drastically reduces power. The truck enters limp mode, restricting performance to protect the drivetrain, and driving becomes difficult or dangerous. The repair requires replacing not just the small actuator, which might seem like it should be a $100 part, but typically the entire turbocharger assembly because the actuator is integrated in ways that make separate replacement impractical. The bill runs $3,000 to $4,500, and the replacement turbocharger contains an identical wastegate actuator that will fail again at roughly the same mileage interval. The engine timing chain tensioner in many modern trucks represents planned obsolescence in its purest form, a component that could easily be designed to last indefinitely but is instead engineered to fail predictably. The timing chain itself, the metal chain connecting the crankshaft to the camshaft, is extremely durable and could last 500,000 miles without issues. But the tensioner, which maintains proper chain tension as the chain experiences minor elongation over time, uses a plastic ratcheting mechanism that wears predictably. This plastic ratchet is under constant spring pressure, clicking into new positions as needed to take up slack in the timing chain. Every single engine start, every temperature cycle, Every vibration causes microscopic wear on these plastic teeth. Eventually, usually between 90 and 120,000 miles, the teeth wear enough that the ratchet can slip, allowing the tensioner to lose its position and the chain to become loose. A loose timing chain creates a rattling noise on startup that sounds alarming because it is. If the chain jumps teeth on the sprockets, valves can contact pistons, destroying the engine catastrophically. The repair, performed before catastrophic failure occurs, requires removing the timing cover, replacing the tensioner, and often replacing the timing chain even though the chain itself shows minimal wear, because labor costs to access these components are so high that replacing everything while you are in there becomes the practical choice. The bill runs $1,800 to $3,500 depending on engine configuration. And the maddening aspect is that the tensioner could use a metal ratchet mechanism instead of plastic, eliminating this failure mode entirely for an additional manufacturing cost of maybe $8, but that $8 improvement would eliminate a $2,000 repair that occurs predictably on millions of trucks. The pattern repeats throughout the entire vehicle. Water pumps with plastic impellers that degrade and fail at 100,000 miles when metal impellers would last 300,000. Alternators with voltage regulators using capacitors rated for exactly the lifespan needed to clear warranty. Starter motors with solenoid contacts made from material that erodes at predictable rates. Air conditioning compressors with clutch assemblies designed to wear out and seize. Every component optimized not for maximum longevity, but for strategic failure timing that generates service revenue while avoiding warranty claims. Understanding this reality changes how you approach truck ownership entirely. You cannot prevent these failures through better maintenance, because they are not caused by neglect. You cannot avoid them through careful driving because they are designed into the components regardless of usage. The only strategies that work involve either accepting the repair costs as inevitable and budgeting accordingly, or escaping the trap entirely by choosing trucks built before manufacturers implemented this planned obsolescence philosophy throughout their designs. Trucks manufactured before approximately 2012, before the current generation of deliberately failure-prone components became standard, use simpler parts engineered without predetermined failure points. Their throttle bodies use cables or early electronic designs without plastic gears. Their fuel pumps use robust motors and metal filter screens. Their transmissions use simpler valve bodies with fewer electronic components. Their turbochargers use mechanical wastegates. Their timing systems use metal tensioners or timing belts with clear replacement intervals rather than chains with hidden failure points. These older trucks will eventually need repairs because mechanical components do wear out, but the failures occur randomly based on actual wear rather than predictably based on engineered obsolescence. More importantly, when components do fail, they can often be repaired rather than replaced, and the parts cost hundreds rather than thousands. A cable throttle linkage that wears can be replaced for $30. A mechanical fuel pump can be rebuilt for $200. A simple valve body can be cleaned and serviced for $400. The total cost of ownership over 200,000 miles becomes dramatically lower because you avoid the expensive predetermined failures that modern trucks experience like clockwork. The manufacturers will never acknowledge this openly because admitting planned obsolescence would destroy consumer trust and potentially create legal liability. But the evidence exists in service bulletins, warranty claim data, and the consistent failure patterns that independent mechanics observe daily. When every truck of a specific model experiences the same failure at roughly the same mileage, that is not coincidence or bad luck. That is engineering working exactly as designed, maximizing profit by ensuring your truck needs expensive repairs at predetermined intervals, turning reliable transportation into a subscription service where major repairs are not possibilities but scheduled inevitabilities. Understanding which hidden parts are designed to fail and when lets you prepare financially or choose trucks that avoid these traps entirely, but either way, the pattern remains. Your truck was engineered to need repairs at 100,000 miles, and it will, because that is exactly what it was designed to do.